The coordinate axis system and graphing ordered pairs. Hey, first let's start with this. We got the number line. We remember that. There's 0, 1, 2, 3, 4, 5. We go east or we go west, positive, negative. We can do that, but all you really need to think of is in the coordinate axis system, the x-axis, that's like the x number line. Negatives, positives. The y-axis is like the y number line. There's 0 and there's the positives and then there's the negatives. So it's two number lines crossing, so it's two-dimensional. Then we have these points, 2, negative 3. X comes before y in the alphabet, so the x coordinate comes before the y coordinate in every pair. So, that point right there, where is it? Well, from the origin, we go 2 units this way and down negative 3 to get here. And maybe a better way to think of it is, it's the intersection of this line where x is 2 and this line where y is negative 3. So either way you get to that point right there, that's where the point 2, negative 3 is. This point, negative 4, 2, hey, in the x direction you're going negative 4. So you're going over to negative 4, and then you're going up 2 in the y direction. That puts you right there, negative 4 and up 2. Now, let's suppose it's 40 years from now and you are living the dream. You've got a great career, you're nearing retirement because you did well in your math classes and established a fantastic, well-paying career, or you raised a family, or both. Life is good. Me, 40 years from now, I'll be in an assisted living retirement home, also living the dream. Lots of shuffleboard, bingo, staring off into space. It's going to be great, baby. So at any rate, here I am. I'm at the retirement home right here. And let's suppose early stages of Alzheimer's are setting in, and I go for walks every day, and I kind of get lost. I forget where I am, so they have to come find me. But that's okay. I've given the staff at the nursing home an understanding of the coordinate axis system so they can use the walkie-talkies I bought for them and locate me and bring me home. So let's suppose I wander 2 blocks this way and 3 blocks this way. Where am I? Well, they bust out the GPS and the walkie-talkie, and they know that I'm at the location 2, 3. So it's all good. If I end up down here the next day for no reason at all, I go 3 units this way and 4 units down, no problem. I've gone 3 in the x direction and down 4 blocks to the south, so I am at the point negative 3, negative 4. So even though the memory ain't what it used to be, I've got things in place for my retrieval on a daily basis. It's all about planning. Now here's the deal. You got a coordinate axis system. You have 4 quadrants. 1, 2, 3, 4. Think of the first quadrant being the most important, where all the x and y values are positive. There's 4 points over there. If both the x and the y coordinate are positive, we're in the first quadrant, 2 to the right and up 6. So this point is going to be 2 to the right and up 6. Boom. Point A is in the first quadrant. When the x coordinate is negative and the y coordinate is positive, then we've gone negative on that x number line. We've gone negative, but in the y direction, we've gone positive. So the point negative 2, 6, this point from here is negative 2 and up 6. So it really should be a mirror image of point A. It's just as far on the left side of the y-axis and then just as far up. Point C, both the x and the y coordinates are negative, so from the origin, we're going to the left 2 on the x number line, or the x-axis, and down 6 on the y number line. So this point is going to be down yonder. Finally, point D is in the fourth quadrant. It should be over here, because it's going to be going 2 to the right and down 6. Simple as that. It's really not bad. X before Y in the alphabet, sing the song if you need to, and X before Y in ordered pairs. Finally, it's important, I think, for us, even if the problems in textbooks don't necessarily give us a context, it's nice to understand that, hey, the x-axis could take on very important information. The x-coordinate could be the hours that you've been awake, and the y-coordinate might be the ounces, that's OZ period. Okay, I'm a wizard at writing that. But anyway, so the ounces of water consumed since you've woken up. Well, look at these ordered pairs. Look at these points. There's the point 110. It's important right there. Can you interpret that point? Well, sure. If you think about X being number of hours, then after 1 hour of being awake, we've consumed 10 ounces of water. Now notice this graph. It's not linear. We're going up here and then we're staying steady, jumping up a little bit, staying steady, and going like this. Suppose it's a school day. Can you explain this point, the point 310? Well, by golly, That means after 3 hours, you've still only consumed 10 ounces of water. It means you've been sitting in class, you haven't gone by the drinking fountain, you may be starting to see stars in the classroom. So that point has very important information, 2 pieces of information. How many hours have you been awake, and how much water have you consumed since you woke up? Now, if you think about it, can you put a story together for why at the 4th hour you're up to 15 ounces of water consumed? That's right, you probably finally got smart and said, I better swing by the drinking fountain and get some water. All right, and then after that, how do you explain that at the 5th hour you're up to 30 ounces? Correct again, you went to lunch, but then you sat in class, no more water was consumed. Then you finally did what? You made it home or to the locker room or something like that, and you had to consume some more water. So by the time you get to this guy, you finally have 50 ounces of water in your system after 8 hours. But at any rate, relate to the problems. Most graphs, you guys, read the x and the y-axis if it's available for you. We usually deal with information in real life that's just in the first quadrant, but first quadrant, second, third, and fourth. All right, good luck.